Hi everyone, here's the final review for Advanced Algebra A. I'm not going to go through every one of these questions because there are several that when I do them, you'll be able to get the next one that's right after it because the process is kind of the same. So here's question number 1, and the directions are to put it into slope-intercept form, so that means get y all by itself. So let's get this 4x off to the other side by subtracting 4x. So then we have a negative 3y on the left side. That equals a negative 4x plus 10. Now we divide both sides by a negative 3, and y is all by itself. So y equals a negative 4 over a negative 3 is a positive 4/3 x, and 10 divided by a negative 3 is a negative 10/3. So there's your answer in slope-intercept form. For question number 5 and 6 here, it says for the following functions, f of x and g of x, find f of 6. So that means 6 is going to go in for each x. So what is f of 6? It equals 3 times x minus 2. And x is the number 6. So it's 3 times 6 minus 2. So it's 18 minus 2. And 18 minus 2 is 16. So our answer for question number 5 is 16. For number 6, it says find g of a negative 2. So into our g function, we're going to put negative 2 in for every x that we see. So g of a negative 2 equals 3 times x squared minus an x plus 6. And our x is a negative 2. So a negative 2 squared is a positive 4, so it's 3 times 4 minus a minus 2, so that minus and minus makes a plus. Plus 6, 3 times 4 is 12, plus 2 plus 6 is 20. The answer to question number 6, g of a negative 2 equals 20. For question number 9 here, it's find the equation of a line, and we want to have this in slope-intercept form. So we're going to put it into y minus y1 equals m times the quantity x minus x1. That's how we find the equation of a line in point-slope form. You have a point and you have the slope. So it's y minus a minus 8. Y minus a minus 8. That equals m times the quantity x minus a minus 3. And our m is the number negative 5. So we'll put this into slope-intercept form. Minus a minus makes a plus. So we get y plus 8. That equals a negative 5x when you distribute minus 15. So our answer, getting y all by itself, subtract 8 from both sides, y equals a negative 5x minus 23. Slope-intercept form of that line. Question number 12, to put this one in slope-intercept form, I first have to find the slope. So slope is equal to y2 minus y1 over x2 minus x1. So I'll call this point x1, y1. I'll call this point x2, y2. So our slope equals 0 minus a minus 1 over a negative 1 minus 3. 0 minus a minus 1 is plus 1. A negative 1 minus 3 is a negative 4. So my m is a negative 4th. So now I could pick either one of these 2 points, and now that I have the slope, I can do point-slope form, which again is y minus y1 equals m times the quantity x minus x1. And I can use either one of these points. I will use this one. So y minus the y coordinate, y minus a minus 1. That equals the slope that I found, which was a negative 1/4, times the quantity x minus the x coordinate, and the x coordinate is 3. So again, I'm now going to do the same thing as I did on the last problem. I'm going to distribute the slope. So I have y plus 1 equals a negative 1/4 x plus 3/4. Negative 1/4 times negative 3 is a positive 3/4. And then I'm going to subtract 1. Subtract 1. So y equals a negative 1/3 x. 3/4 minus 1 is a negative 1/4. And there's my answer for question number 12. Question number 14, write the equation of this line in slope-intercept form. To write an equation in slope-intercept form of y equals mx plus b, I need to know what m is and I need to know what b is. B is where it crosses the y-axis, so right there, that's where it crosses the y-axis. So my b is 1. And my slope is how do I get from one point to another point? What's my rise over my run? So my rise is down 1, 2, 3 to the right 1. Down 1, 2, 3 over 1. So down 3 over 1 is my slope. And my y-intercept is 1. So my answer, y equals m, which is a negative 3, x plus b plus 1. There's the answer for question number 14. Question number 16, we want to find an equation of a parallel line and a perpendicular line to this line that goes through this point. So parallel slopes are the same. So this line, its slope is a negative 2, so my m is going to be a negative 2. And then I'm just going to simply put it through this line, or that point, sorry. So it's y minus the y coordinate, y minus 2, that equals our m, which is a negative 2, times the quantity x minus the x coordinate, x minus a minus 3. So to put this into y-intercept form, y equals mx plus b, negative 2x, and then a negative 2 times a positive 3 is a negative 6. So then I add 2 over, so y equals a negative 2x minus 4. And I add 2 to both sides, a negative 6 plus 2 is a negative 4. So that's the parallel line. The perpendicular line, perpendicular slopes are opposite reciprocal. So this slope right here is a negative 2. So the perpendicular slope, m equals a positive 1/2. It's opposite, so it's negative goes to positive, and it's the reciprocal. 2 over 1 goes to 1 over 2. So now I'm going to put this slope through this point. So it's y minus the y coordinate, y minus 2. That equals our perpendicular slope, which is 1/2 times the quantity x minus the x coordinate, x minus the minus 3. So y minus 2, that equals 1/2 x. 1/2 times 3 is 3/2. And then I'm going to add 2 to get y all by itself. Y equals 1/2 x plus 1.5 plus 2 is 3.5, which is 7/2. There's the answer for question number 16. We're going to graph each inequality here for question number 18. So my y-intercept, my b is a 1. My slope is 3, so it's a rise of 1, 2, 3, run of 1, which is the same thing as going left 1, down 3. So left 1, down 1, 2, 3 is right there. Left 1, down 1, 2, 3. There's my line right there. Now because it's less than, I'm going to connect these points with a dotted line. If it was less than or equal to or greater than or equal to, I would connect it with a solid line. But this one I'm going to connect with a dotted line, and I'm going to shade on this one. It says y is less than, so less than means below. So I'm going to shade everything below the line, which is right there. Question number 20, solve by using substitution. So right now I have a variable all by itself. Y is all by itself, so I'm going to put 3x minus 4 into this y. I'm substituting it in. So a negative x plus y equals 4. And our y equals 3x minus 4. So I'm going to put 3x minus 4 into the y. Now I'm going to solve. A negative x plus 3x minus 4 equals 4. So negative x plus 3x is 2x. And I'm going to add 4 to both sides. That equals 8. So x equals 4 when I divide both sides by 2. So my x-coordinate is 4. My y-coordinate, I could simply put x into here or to here. It doesn't matter which one to solve for y. So y equals 3 times x minus 4. And we just found our x to be 4. So 3 times 4 is 12. 12 minus 4 is 8. So 4, 8. There's our answer for question number 20. Question number 21 is the same thing. Question number 22, I'm now going to solve by elimination. So if I want to solve by elimination, I want to get the variables to be the exact same. or the coefficients in front of the variables to be the same, except one being positive and one being negative, and then I'm just going to add them up. So I'm just going to multiply this one by a negative 1. I'll keep this one just the way it is, and then this top formula equation, a negative 1 times 4x is a negative 4x, a negative 1 times 2y is a negative 2y, and a negative 1 times 15 is a negative 15. Now I'm dealing with these two equations, and I'm simply going to add them up, and my y's will be eliminated. 2x minus 4x is a negative 2x. My y's are eliminated. 2y minus 2y is gone, and that equals 7 minus 15 is a negative 8. Divide both sides by a negative 2, so I get x to equal a positive 4. So x equals 4. I now have to find what my y is. And again, I could use either of these two equations to solve for y. It doesn't matter which equation I use. So I'll use the top one. 4 times x, and we just found x. X is 4, so 4 times 4 plus 2y equals 15. So 16 plus 2y equals 15. 2y equals 15 minus 16 is a negative 1, so y equals a negative half. That's your y coordinate. 4, negative 1/2. And again, question number 23 is really the exact same process. Okay, when we divide, I taught you how to use synthetic division, so we're going to use synthetic in this case. So that's where we have this division bar. We pull the coefficients out from here. So it's 1x to the 4th, 4x cubes, 3x squareds, a negative 1x, and a positive 2 constant term. And then our divisor, remember how when we see x plus 2, we do the opposite and put a negative 2 out in front. And then we're going to bring this 1 straight down. And then we're going to multiply, add, multiply, add, multiply, add with that algorithm. So 1 times negative 2 is a negative 2. Add, we get a positive 2. Multiply 2 times negative 2 is a negative 4. Then we're going to add 3 to negative 4, make a negative 1. Then we're going to multiply a negative 1 times negative 2 is a positive 2. Then we're going to add a negative 1 and a plus 2 is 1. Then we're going to multiply 1 times negative 2 is a negative 2. And our remainder is 0. So this is our answer, and it represents our coefficients from 1 power down of x to the 4th. So here is 1x to the 3rd plus 2x squared minus 1x plus 1. That is our answer for question number 27. Question number 28, very similar. It's x cubed plus 27 divided by x minus 3. So we're going to have our division bar. Now remember, we have to have placeholders. So there's 1x cubed, 0x squareds, 0 x's, and 27 for a constant term. And then our 3 comes out in front. So we're going to drop our 1 straight down. 1 times 3 is 3. Add 0 plus 3 is 3. Multiply 3 times 3 is 9. Add 0 and 9, make 9. Multiply 9 times 3 is 27. And add 27 plus 27 is 54. So 54 is our remainder. So x cubed is my highest power. So this number represents my x squared. So there's 1x squared. And then I just go down in descending order from there. Plus 3x plus 9 plus 54 is my remainder. And I put it over the divisor of x minus 3. There's the answer to question number 28. Okay, let's factor these. Hopefully you guys are comfortable with this now. You form two separate parentheses when you see a trinomial. If you can't take out a GCF, x times x is x squared. And we have a negative 10 times a positive 5 gets you a negative 50 with that negative 5x in the middle. So there's your answer. You could FOIL every one of these to make sure you have the right answer. Number 30, 5x times 1x gives you 5x squared. 15 if I do a negative 5 over here and a negative 3 right there. A negative 3 times negative 5 is a positive 15. And then we have negative 25 minus 3 gives our negative 28. So for number 30, there's our answer. Number 31, when you see two terms, you should think the difference of two squares. So the difference of two squares, the square of the first term goes in the first terms of the binomial. The square root of the second goes in the second terms of the binomial. And then 1 is a minus sign, 1 is a plus sign. X minus 9 times x plus 9. Number 32, you see a trinomial. You can't take out a GCF, so you're just going to try to factor it like normal. X times x is x squared. A negative 7 times a negative 2 is a positive 14, and that gets you the negative 9x in the middle. 33, again, you have the difference of two squares. So with the difference of two squares, the square root of 25x squared, which is 5x times 5x, the square root of 49 is 7 times 7, and one binomial has a negative sign, one binomial has a positive sign. 34, this one you could take out a GCF first, and that would make it easier to factor. So if you take out a 4 out of every single term, you would get x squared plus 4x plus 4. So then it'd be 4 times a binomial. It's x times x, and that gives x squared. Factors of 4, 2 times 2 is 4, and then 2x plus 2x is 4x, and that gets you that in the middle. So this is our answer. If you want to, you could write it as 4 times x plus 2 squared. That's the same thing. Okay, when we add polynomials, we just combine like terms. So x to the fifths can only be combined with other x to the fifths. And then x to the fourths would be next, and there's 3x to the fourths. And then we would add x cubes next. There's 5x cubed here and a negative 3x cubed there. So 5 minus 3 is 2x cubed. Takes care of the x cubes. X squareds come next. Combining like terms, a negative 2x squared. That's all I see. So minus 2x squared. X's are next. 1x and 7x make 8x. And then constant terms comes last. A negative 6 and a positive 3 make a negative 3. So we have combined like terms. That's adding polynomials. When I subtract polynomials, it's really the same thing, just only with one additional step. We have to distribute the negative sign to every term in the polynomial. So we still have 3x cubed plus 5x squared minus 4x minus 1. But now we have a negative 2x cubed, a positive x squared, a minus 7x, and a plus 7. Now I'm just going to combine like terms. So there is 3x cubed and a negative 2x cubed, making 1x cubed. There's 5x squareds plus 1x squared. That leaves 6x squareds. A negative 4x and a negative 7x is a negative 11x. And then negative 1 and a positive 7 make a positive 6. When we multiply, we take the coefficient times the coefficient. So 2 times 3 is 6. And then with common bases, we add their exponents. So x squared and x squared make x to the fourth, and y to the third times y to the fourth is y to the seventh. So we multiply the coefficients, we add the exponents. So 2 times a negative 4 is a negative 8. X squared times x is x to the third. 2 plus 1 is 3. Y to the third times y to the second is y to the fifth. There's the answer to question number 38. Okay, for these ones, we're simplifying with monomials. With common bases, you add exponents. 3 plus a negative 2 is 1, and then 1 plus 1 more is 2. So our answer, x squared. Number 40, we would subtract. So 4 minus 7 is y to the negative third. But we can't have negative exponents, so that's the same thing as 1 over y to the positive third. Or you could think of it, if there's 4 y's in the numerator, 7 y's in the denominator, 4 of them would cancel out in the numerator and denominator, and there's 3 left in the denominator. So 1 over y to the third. 41 would be a squared. 5 minus 3 is 2, so a squared. 42, when you have a power raised to a power, you multiply. So it's p raised to the 40th. That's the correct answer for number 42. 43. You would take the coefficient and raise it to the third. So 4 times 4 times 4 is 64. And then with the variable, when you have a power raised to a power, it's like x to the first raised to the third. You'd multiply those. 1 times 3 is just 3. 64x to the third. Number 44, 5 squared is 25. X to the ninth squared, you would multiply 9 times 2 and get 18. All of that is divided by z to the sixth. So that's that one. 45, we will divide the coefficients. 32 divided by a negative 2 is a negative 18. A divided by a to the seventh, that's a to the sixth in the denominator. And b to the fourth divided by b to the first is b to the third in the numerator. 4 minus 1 is b to the third. 46, we're first going to do this operation where we're going to square 3a to the fifth, b to the fourth. So this 3ab is still just going to hang out for a little bit. 3 squared is 9. A to the fifth squared, you'd multiply 5 times 2 and get a to the 10th. Multiply 4 times 2 and get b to the 8th. Now we're going to multiply that with the 3ab. So we'll take coefficient times coefficient. 3 times 9 is 27, and add exponents. A to the first and a to the 10th make a to the 11th. B to the first, b to the 8th make b to the 9th. Question 47. The square root of 4 is 2. The square root of x to the fourth is x squared. Remember the variables we divide by 2. So 4 divided by 2 is x squared. 6 divided by 2 is 3, so you get y to the third. Number 49. In order to add and subtract radicals, they have to be exactly the same. The radical does. So if we break down these radicals, 25 times 2, 9 times 3, 4 times 2, 16 times 3, then you would get the square root of 25 is 5, so you get 5 root 2. The square root of 9 is 3, so you'd get 3 root 3. The square root of 4 is 2, so it'd be 2 root 2. The square root of 16 is 4. Now you could combine like radicals. So 5 root 2 minus 2 root 2, this right here, is 3 root 2. And then a positive 3 root 3 and a positive 4 root 3 make a positive 7 root 3. There's the answer for question number 49. Question number 51. It is improper to have imaginary numbers in the denominator, so we're going to get rid of the imaginary number by multiplying both top and bottom of the fraction by I. The reason why we do that is because 3i times I in the denominator is 3i squared. And then I squared is the same thing as a negative 1. So it's kind of like saying 3 times a negative 1, which is a negative 3. So now we don't have any more imaginary number in the denominator. In the numerator, I times 2 is 2i, and I times 3i is 3i squared. And again, I squared is the same thing as a negative 1, so it's like taking 3 times a negative 1. So 3 times negative 1 is a negative 3, and then we still have this plus 2i. And that is our answer for question number 51. Question number 52, when there's a binomial with imaginary numbers, you got to multiply by the conjugate, which is 2 minus I. Multiply by 2 minus I. So in the denominator, you take 2 times 2 to get 4. Outside term when you FOIL would be a positive 2i. Inside it would be a negative 2i, and those would cancel. And so then last times last, I times a negative I is a negative I squared. In the numerator, when you FOIL, first times the first is 2. Outside 1 times a negative I is a negative I. Inside, a negative 3i times 2 is a negative 6i. And last times last, a negative 3i times a negative I is a positive 3i squared. So these I squareds make negative 1s. So it's 4 minus a minus 1. So 4 plus 1 is 5. This 3 is times a negative 1. So 3 times a negative 1 is 3. So then this 2 and the negative 3 make a negative 1. And then a negative I minus 6 i's is a negative 7i. So there's the answer for question number 53. 61. We're going to subtract 7 from both sides to get the radical 2x plus 3 by itself. And then, to get rid of the radical, the opposite of square rooting is squaring. So 2x plus 3 equals 9. So 2x equals 6. 9 minus 3 is 6. Divide both sides by 2. So x equals 3. You can certainly check this by putting 3 right back into x, and the left side should equal the right side. 62, divide both sides by 2. So x plus 4, the square root of x plus 4 equals 10. Now we can square both sides. X plus 4 equals 100. So x equals 94. Oh, sorry, 96. 100 minus 4 is 96. 63, when we add 8, or when we add 4 to both sides, x squared equals a negative 4. So then to square root, the square root of a negative 4 is a positive 4 times a negative 1. So x equals plus and minus. The square root of 4 is 2. The square root of negative 1 is I. Plus and minus 2i. Okay, I'm not going to have you write the equation here in vertex form, so you can cross that out. The axis of symmetry is what cuts the parabola in half. So this line right here is the axis of symmetry. It cuts the parabola in half. So that line is x equals 1. X equals 1 is the axis of symmetry. What is the vertex? The vertex is that change of direction point. So it's that point right there. And that point is right 1, down 3. 1, negative 3. What is the minimum or maximum value? The vertex is the minimum or maximum value. This time it's a maximum value because the parabola opens down. So the maximum is a negative 3. That's the highest point that the parabola reaches when x equals a positive 1. And then for the domain and range, I have you do that in interval notation. So this parabola goes left forever and right forever. So the domain is negative infinity to positive infinity. And then the range, it starts at negative infinity, and then it goes as high as negative 3 before it starts going down again. So it reaches a height of a negative 3. So that is question number 75. Let me know if you have any questions as you're doing this review on your own.